I'm going to talk to you about what the Ministry of Environment has been up to with respect to groundwater in the past year, 2022. So I'll talk a bit about the science to support the water quantity management initiative in Ontario, a bit of a source water protection update, not nearly as much data as you've just received. Talk about the provincial groundwater monitoring program, another initiative in which the CAs are very involved, and Great Lakes related groundwater activities and research in the province. So many of you already know the content of this slide, but for those of you who don't, Ontario undertook a water quantity management review from 2016 to 2021 in order to ensure that Ontario's water resources are protected and used sustainably in the face of climate change and continued population growth. This included conducting a comprehensive review of the province's water taking policies, programs, and science tools, a review of the state of resources in 7 key areas of the province, as well as at 10 of the water bottling sites in the province. We engaged with and considered the perspectives shared by Indigenous communities, the public, and stakeholders, including a number of stakeholders who participated on an external working group. And this led to amendments to the regulation that took place in April 2021. These enhancements included establishing priorities of water use in the province that can guide water taking decisions. It enabled an area-based approach to assess and manage multiple water takings together in stressed areas. This replaced the old high-use watershed prohibitions that were previously in the regulation. We also enabled making water taking data available and enhancing access to government data, which I'll talk about more in this talk, and requiring water bottling companies to have support of host municipalities before applying for a permit for new or increased water takings. So in terms of science to support this new water quantity regulatory changes, the biggest one is probably making data more accessible. The reported water taking data for the permits to take water have now been published on Open Data Ontario, and I'll speak to that in a minute. MECP is also exploring opportunities to use the Source Protection Information Atlas to make public water data more accessible and usable, perhaps even adding some tools for simple analysis. We're also looking to enhance our existing data, which the OGS is helping us with, and you'll hear more about these talks from Abigail and from Riley, looking both at the water well regulation and the reported well records and standardizing the geological descriptions, and also tying the great work that the OGS has done in mapping and characterization to the PGMN well intake zones. So that's something we're looking forward to, and you'll hear about in a minute. Now, probably our biggest achievement in the last year from a water quantity perspective is posting the 2019 and 2020 daily and annual water takings that were reported to the ministry on open data. It's the first time we've done that. 2021 and 22 will be posted next, and the historical data will be posted as it's completed. The data includes permit to take water number, the year, the source name, the surface and or groundwater resource that's taking from, the purpose category such as agriculture, the specific purpose, it might be irrigation or wide livestock watering, the UTM coordinates and zone, the date of the water taking and the source and the time and the source taking amount. This information can be found on the Ontario Open Data website. If you Google water taking data, you can find it. If not, email me. I'll go back to my email at the end of the talk. You can also find the permit to take water data on the open data set. So here's some examples of the data. You can see the red lines are the approved volume. The length of the red line is the duration of approval in a year for a construction dewatering might be approved for 3 months or 6 months or whatever. But what this really shows, this is just a simple thing you can do with the data that we're now making available. But what it really shows, and I'm probably preaching to the converted on this talk, but is the difference between the volume that's approved, basically everything under this red line, and what is actually taken, which is the blue text. So I think it'll really help people understand a bit more about water taking in Ontario, and I hope so. Now I'm just going to provide a bit of an update on source protection, basically summarizing the wellhead protection areas updated in 2022. The Grand River Source Protection Area completed Tier 3 water budgets for Centre Wellington and Halton Hills. They also added Wapakews to Fergus and Elora. The Hamilton Source Protection Area updated vulnerability scores for a number of wellhead protection areas and updated the delineation and vulnerability scores for Freelton. A number of wellhead protection areas have been changed across the province, primarily to reflect the addition of one or more new wells, and this work is done by the conservation authorities, the source protection committees, and all the people who work with them, the municipalities, etc. So these include a number in Grand River, CTC, South Georgian Bay Lake Simcoe, Trent, Mississippi Rideau, and Saugeen, Grey Sauble, Northern Bruce. Also in all of these, all this work, it's all summarized on one page, but it's a lot of work being done over a couple of years by a lot of people, can be found at the Source Protection Information Atlas. Again, I suggest Googling. If you want the address, though, you can ask one of your CA or source protection colleagues. Now I'm going to speak a bit about the Provincial Groundwater Monitoring Network. This first slide is for those of you who are not familiar with our program. It was established in the year 2000 and is designed to monitor ambient groundwater levels and chemistry conditions across Ontario. The program is managed as a partnership between the Ministry, the 36 conservation authorities, and Severn Sound Environmental Association, which is a collaboration between 7 municipalities. You can see the wells here in the map. It's a bit small, but 490 wells have water levels measured hourly. 130 locations representing 150 of these wells have satellite telemetry, so can report near real time. 115 of the locations have barometric pressure measured to correct the water levels. 390 of the wells are sampled for groundwater quality in the fall. Up to 50 now, starting this year, are also going to be sampled in the spring. Actually, it was started in 2022. And we have about 450 samples that are analyzed at the Ministry Lab for general chemistry, nutrients, major ions, and metals. And 40 of the 490 wells also have rain gauges. The data is managed in the Whiskey program by Kisters, that is an MNRF based program that we collaborate with, and the conservation authorities all have access to that data in Whiskey. Many of them have Whiskey in their own offices as well, but they can all access this data. So, sorry, they're out of order. The next one I'm going to speak now to. We also have, as many of you may recall, because Scott McRitchie used to talk about it, an integrated water monitoring network to assess the climate change impacts for adaptation. So it includes climate stations, as you can see an example here, surface water monitoring, and groundwater monitoring. And these are in 7 locations across the province. They were established in 2010 based on input from climate experts, and they all have telemetry, so near real-time data. So what progress or changes are we making in PGMN? We're working to reduce the time involved in making the data available both to the program partners and the public. So increasing the number of wells reporting real time, ensuring that there is barometric pressure in those wells so that they can be corrected in real time. Working with MNRF to update to the newest whiskey and make sure it's ODA compliant. Streamlining our corrections process and review process for water levels and water quality data so that we can more timely post that data on open data. Anybody who's looked recently sees it's unfortunately been a while. We're also reviewing the integrated monitoring network to determine if we're meeting climate change related and groundwater surface water needs that were intended when it was put in, and looking at the potential to expand. The IJC 2022 report looking at groundwater surface water conceptual framework identified the need for more basin scale integrated groundwater and surface water monitoring. What else are we up to? We have a monitoring network that was established in 2013 up at the Ring of Fire. It's baseline environmental monitoring, and for our component, it's basically groundwater, or more really, peat pore water sampling. We collect data to support long-term assessment of impacts of future development in the region, including individual or cumulative impacts of multiple potential future mines. There are 132 peat pore monitoring wells at 46 sites in bog, fen, conifer forest, peatlands. We take peat water levels, temperature, and conductivity hourly. These are not real time, so we have to go up and collect the data. Mineral soil samples were taken during the installation, and water samples were taken initially. And both of these were tested for nutrients, major ions, and metals. We visited the site in 2022 to download the water level data and inspect and maintain the wells. And this work is done in collaboration and with field participation of the Martin Falls First Nation, who we thank very much for this. Now I'm going to speak a bit about the Canada-Ontario Agreement. Some of you may have seen these slides before. The Canada-Ontario Agreement on the Great Lakes Water Quality and Ecosystem, otherwise known as COA. The purpose of this is to understand how groundwater influences Great Lakes water quality and ecosystem health, and to identify priority areas for action. Key actions include improving the understanding of groundwater impacts and stressors on Great Lakes water quality and ecosystem health, identifying priority areas for monitoring, management, and action, and updating binational groundwater science. New concepts in the 2021 COA that weren't there before and aren't specifically enunciated in the Great Lakes Water Quality Agreement, the binational agreement, are the role of good quality groundwater and groundwater surface water interaction studies and modeling. So taking the old concept of groundwater as a contaminant or pathway of contaminant for dirty groundwater, and putting the science in that helps people understand the role of the good groundwater, and really understanding, how groundwater impacts those receptors. Other annexes in COA also apply to groundwater. This includes nutrients, harmful pollutants, wastewater and stormwater, and climate change, and the need to move from the science and the research, the awareness, to action and implementing management tools. The Métis and First Nation components or annexes also, of course, have relevance to groundwater. So, update on the groundwater activities in Ontario. Key binational achievements supported by Ontario include completing the Great Lakes Science Report entitled Groundwater Science Relevant to the Great Lakes Water Quality Agreement 2022 update. It's actually going to be published in 2023. Ontario Ministry, Conservation Authority, and academic participation from Ontario was solid, and you'll see when the report comes out, authorship from ministry staff, Conservation Authority staff, and Ontario academics. Also, Ontario was very involved in the development of the 2022 State of the Great Lakes Groundwater Quality Sub-Indicator, addressing spatial data gaps in groundwater quality, specifically nitrate and chloride, and the Ontario government was responsible for developing the groundwater mapping and working with the American and Canadian partners to achieve that and complete the report. Ontario also sat on the steering committee for the IJC report, Development of the Great Lakes Groundwater and Surface Water Conceptual Framework. Groundwater-related research being undertaken and funded by the ministry tied to the Canada-Ontario Agreement include groundwater modeling, groundwater surface water interaction, groundwater and climate change impacts and mitigation, and also from a contaminant side, PFAS, salt, septic effluent, and nutrients. And you'll be hearing from a number of the researchers that are funded through COA today and on Thursday. If you want additional information on what we've been up to, both at the province level, the federal level, and other, you can look at the 2022 progress report of the parties pursuant to the 2012 Canada-United States Great Lake Water Quality Agreement. If you Google 2022 progress report of the parties by national.net, you should find that. And then one specific activity that we've been quite involved with is PFAS and groundwater. The Canada-Ontario Agreement research projects to better understand the prevalence of PFAS in the environment included funding to Environment Canada to look at groundwater transport of leachate from old closed landfills in Ontario as a potential source of harmful pollutants, including PFAS. And Jim Roy spoke on this project last year. You can see a graph from that research project. The final report has been published, Prop VR et al. 2021. And you can see the sum of PFAS detected in leachate affected groundwater samples from 20 Ontario historic landfills in that picture. That project has been complete. There's also an ongoing project being done with the military college in RMC in Kingston. It's estimating number of potential PFAS sites in Ontario through risk-based assessment of land uses, for example, industrial sector, waste, etc. That project is ongoing, and at some point there should be a posting of the findings of that, hopefully in the next year or so. We're also doing work internally at the province. PFAS in groundwater is a concern, both recent studies under COA, but also studies from elsewhere suggest that landfills are a likely source of PFAS and PFOS and may impact groundwater that has the potential to contaminate drinking water or irrigation wells. In Ontario, there are approximately 805 active landfills and over 5,000 closed municipal landfills. We initiated this project in 2019 to look to sample PFAS at approximately 20 landfills, and that number is just coincident. It is not the same 20 landfills as in Jim and McMaster's project. Across Ontario to provide information on PFAS across a range of site conditions and landfill sites. Landfills were selected based on risk-based criteria such as private drinking water wells within the monitoring program, landfill design, landfill age and size, geology, hydrogeology, and additional environmental data. Samples of private well, groundwater, leachate, surface water, etc. were collected from landfill locations between 2019 and spring 2022, and samples are continuing to be sampled through the summer of 2023. So it'll probably be a year or more before you hear a report back from us on this work, but that's what essentially some of the stuff that Ontario and the Ministry of Environment has been up to in the past year. I will just go up to the first slide so you can see my email. You can contact me at this email, heather.brody-brown@ontario.ca, if you have ongoing questions or want to know who to speak to about any of the information I've provided today. Thank you.